Amin, amin, amin. Okay, so thank you everyone. So today kita start dengan dalam Zoom. Kita gunakan Zoom terlebih dahulu. Kalau I'm not sure about the Google Meet, but according to our ICT team, the Google Meet should be okay by tomorrow. Okay, so if your other lecturer try to use the Google Meet today and it works, so please acknowledge me. Okay, so that on the next class, definitely we will use Google Meet. But for now, for today, for our session today, we will continue using this Zoom platform. Okay, so I hope that everyone should okay with your Wi-Fi or maybe your LAN connected. I should remind you also that there will be another place instead of your room or instead of your hostel in Bucha Alam. You can also do some ODL session in the lab, in the computer lab. Okay, computer lab, tapi bukan dekat area hostel lah, kena turun ke bawah lah. Alright, there will be a place for you to, if you can bring your own laptop together. Okay, maybe if you don't have any laptops, okay, maybe you can. Okay, I'm sure that if you are using a handphone, it will not be suitable because the screen is quite small. Okay, but in fact you will have other options. Okay, the information given by our ICT team, the lab, the computer lab, okay, have a lot of okay, senang cerita computer lab tak banyak sambutan lah. Okay, so kalau kamu nak pergi ke computer lab, okay, you should go to computer lab so that boleh guna apa kemudahan dekat situ. So don't bother much about other things. Okay, so mana-mana yang kamu rasa sesuai. But they are in the process of upgrading. Okay, upgrading the internet in Puja Alam. So please be patient. Okay, so at now we will continue. I will play a video for you to look and to see, to watch the videos of the topics, our next topic, which is force and its applications. So it will take some time, maybe after one video, so we will continue, we will try to discuss. Okay, because in these 4 parts of the video, okay, it contains a lot of examples. Okay, of course, if you don't understand, try to keep up, try to catch up with the every examples should be in the videos. Okay, maybe some of you already watched the video, so you can watch it again, and maybe you can drop the questions in the chat box. Okay, for me to answer anything from you. Okay, right. So I'll play the video. Okay. Okay, can everyone? Boleh dengar ke? Semua orang boleh dengar ke? Can everyone hear it?
Yes, sir.
Boleh ke? Boleh dengar ke?
Boleh.
Boleh ya? Okey. Teruskan. Okay.
Sir, tak dengar video ni.
Saya tak dengar.
Saya tak dengar.
A force is a push or pull. An object at rest needs a force to get it moving. A moving object needs a force to change its velocity. As you can see, this is the direction. This is the
Dengar dah.
Sekarang dengar. Okay, kita ulang
all
balik.
of you. I am in the Bermuda. So now we will proceed with chapter 4, Newton's laws of motion. These are the subtopics that we will discuss. 4.1, force, weight and mass. 4.2, the laws of motion. And 4.3, the normal and kinetic friction forces. Lesson outcomes, at the end of this lesson, you should be able to define force, weight and mass, differentiate between contact forces and field forces, state Newton's law of motion, and apply Newton's first and second law for static problems, and also for moving object. A force is a push or pull. An object at rest needs a force to get it moving. A moving object needs a force to change its velocity. As you can see, this is the direction of the force. And direction of the force must be in the same direction as the motion. Force is a vector, meaning that it has magnitude and direction. There are 4 non-fundamental forces of nature. Number 1, strong nuclear force. Number 2, electromagnetic forces between electric charges. Number 3, the weak nuclear forces. And number 4, the gravitational force. All these forces we call as field forces. Then we have another one, that is contact forces. You can see in this diagram, all these examples are contact forces. What is contact forces? Contact forces are forces that act between two objects that are physically touching each other. And then the other one is, the other type of force we call as field forces. These are the example of field forces. Okay, now we will discuss about weight. The weight of an object on the Earth's surface is the gravitational force exerted on it by the Earth. W equal to mg, and the SI unit for weight is Newton. And how about mass? Mass is the measure of how hard it is to change an object's velocity. Mass can also be thought of as a measure of the quantity of matter in an object. Apparent weight. Your perception of your weight is based on the contact forces between your body and your surroundings. As shown in this figure, this person is in the elevator and this elevator is accelerating upwards. This is the direction of the acceleration. From here, we can sketch the free body diagram. In this free body diagram, there are two forces, which is WA and also W. What is WA? WA stands for apparent weight, and W here is the actual weight. From this free body diagram, we can write down the equation. WA, apparent weight, WA minus W, because the actual weight, the direction of the actual weight is pointing downwards, equal to MA. You can see here the acceleration and WA, they are in the same direction. So both are positive here, WA and also acceleration. And then write down the equation, write down WA or apparent weight as a subject. So it will be WA equal to MA plus W. Okay, what is the formula for W just now? W equal to mg. Then you can factorize the m here. M in bracket A plus G. So this is apparent weight. So apparent weight equals to MA plus mg. So from this formula, we know that when the elevator is accelerating upwards, WA or apparent weight will becomes more than the actual weight. Okay, 4.2 Newton's law of motion. There are 3 Newton's law of motion. The first law of motion, which is about law of inertia, and then second law of motion, and third law of motion. Then from the Newton's second law of motion, okay, we have the formula which is F equal to ma, total F equal to ma. How to apply this Newton's second law of motion to solve problems? Yeah. Okay, so the first step, you have to identify the object whose motion is considered, and then determine the forces exerted on the object. So when you know the forces exerted on the object, then you can draw the free body diagram, or we call as FBD, for each object. Let's say there are 2 objects, then you must draw 2 FBDs. Then, according to the acceleration direction of the object, write an equation for x-axis, which is total Fx equal to max, and the equation for y-axis, total Fy equal to may. Now we will discuss the relation between F and A, From here, the formula is total F equal to ma. More force means more acceleration, meaning that when there are more force, there are more acceleration. Why? Because F and A, they are directly proportional. The same force exerted on a more massive object, okay, what happened? If the same force exerted on a more massive object, what happened to the acceleration? Acceleration will decrease. Why? Because M and A, they are inversely proportional. And SI unit for force is kg meter per second square, and combination of this unit we call as Newton. Okay, again, this is about free body diagram, but I want to show you how to sketch the free body diagram and apply the Newton's second law of motion to solve the problems for forces in 2 dimensions. The first step, draw a sketch. For one object, draw a free body diagram showing all the forces acting on the object. As you can see in this diagram, there are one object here. And then you have vector A, which is FA, and you have vector B, this is FB. Okay, then resolve vectors into components. Resolve vector into components X and component Y. And then apply Newton's second law to each component and then solve the problems. As you can see here, you have 2 forces, which is FA and also FB. FA, it is in the first quadrant, while FB in the 4th quadrant. So for FA, you have to resolve into F at X. This is the direction of F at X, and this is FAY. So you have X component and Y component. For FB, this is the direction of FBX, and this is the direction of FBY. Okay, so this is how to resolve into X and Y component that you have learned in vector. And what is this? This is the resultant vector. And don't forget to write down the angle here. This is 45 degrees and this is 37 degrees. You have to resolve into cos and sine theta. Okay, you may try this example at home. Example 2. The normal forces and kinetic friction forces. First, we will discuss how to draw the free body diagram for weight, which is W equal to mg. So how to draw the weight, the FBD for weight? It is from the center of the object and then pointing straight down here. And then how to sketch the free body diagram for normal force? Normal force, this is normal force and it is always perpendicular to the surface. So you have this horizontal surface and then normal force is perpendicular to the surface. Then friction force, it is always oppose the motion direction. Let's say this is the direction of the force, so friction force will be in the opposite direction. And this is the formula for friction force, Ff equal to mu n. Mu here stand for coefficient of friction and n here stand for normal force. For tension, the direction of tension T1, here there are T1 and T2. Direction of the tension always away from the body. So this is the body. So it is away from the body. Same as this one. This is the body. So it is away from the body. For smooth pulling, T1 equal to T2. Okay, there are two different surfaces here. This is horizontal surface and this is an inclined surface. How to draw the free body diagram for horizontal surface? This is horizontal surface but there are an applied force here. Okay, so as usual there are normal force here and this is mg, which is weight, and let's say this is a rough surface, so there are friction force and this is the applied force. Okay, then for incline surface, the same thing that we have to do, sketch the free body diagram. This is the weight, which is from the center and then straight down here. Okay, you draw the free body diagrams on the object. Okay, so from the center here, straight down here is the mg and this is friction. Yeah, friction force, because the direction of the motion is in this direction. Okay, then we have normal force, which is perpendicular to the surface. This is the surface, right? And then normal force must be perpendicular to the surface. Okay, an object sliding down an incline has three forces acting on it. Okay, we have normal force, gravity, and frictional force. Okay, then from free body diagram for horizontal surface and inclined surface, we want to write down the equation. How to write down the equation? First, if you look at this diagram, okay, there are two forces, this free body diagram, which is R and also mg. Okay, R, I write down here as R because it is stand for reaction force. We call reaction or normal force. But if you refer to your textbook, they use N here, yeah, stand for normal force. So you can use R or N, yeah, okay. So from here, the equation R and mg, there are along y-axis. Okay, there are along y-axis. So total F equal to 0. And then R will be positive R or N. Yeah, normal force. Normal force minus mg. Why this minus? Because mg here, mg is pointing downward, while n is pointing upward. Okay. From here, you will write the equation, which is n minus mg equal to 0. R equal to mg. When you rearrange this equation, you will get R, or again, we can write down this one as n. Yeah. So N equal to mg, which is normal force equal to mg. Okay. Next, for inclined surface here. Okay. Just now, I have shown you how to draw the free body diagram. Yeah, normal force. This one again R, you can also write down as N, which is stand for normal force. Okay, normal force must be perpendicular to the surface here. Yeah, to the surface. Normal force must be perpendicular to the surface. Okay, and then this is the mg, which is from the center, mg, and then straight down here. Okay, and you can see that this mg, you need to resolve into x and also y component. So this one will be, this is the angle, which is same as this angle. Okay, this one mgy will be mg cos theta, because we consider the angle is here. Okay, and then this one will be mg, x will be mg sin theta. Okay, how to write down the equation for y component? Yeah, for y component, you can see we have normal force and downward we have mgy, which is mg cos theta. And then you write down the equation r minus mg, but this is for y component, equal to 0. Okay, why this is negative? Again, mgy here. Yeah, look at the arrow here. It is pointing downwards. Okay, so r minus mgy equal to 0. And mgy we resolve into y component, which is mg cos theta. So r minus mg cos theta equal to 0. And then you bring this mg cos theta on the other side, what will be, and then we will get r equal to mg cos theta. Okay, then the last slide, exercise 1. Please draw free body diagram for figures below. Yeah, there are 4 different figures here. Please try to solve this. Yeah. Okay. Bye. Thank you.
All right, everyone. So let's take a look at what you should know. What you should learn in this video. So it starts with the force. Okay. So in this by the end of the lesson, this lesson, students should be able to define force, weight, and mass, differentiate between contact forces and field forces, and state the Newton's laws of motion, and of course how to apply the Newton's first and second law. Okay, so this is all about force. Okay, and later in the next video we'll see how force will influence in the applications. So this is actually all about force, and afterwards we will look at the way, we will watch the video together about how to use this kind of force in the real situations. So you actually the madam I have already said about how to use the force. Okay, so this is the field forces and the contact forces. Okay, and of course the definitions of weight. Okay, so maybe some of you may have a misinterpret about a weight and mass. That's common thing, because definitely when people ask you what is your weight, you tend to say that my weight is 75 kilogram, my weight is 60 to 60 kilogram. For example, the kilogram means mass. Okay, it's not weight. Weight is must be in Newton, because it should be mass times with the gravity. Okay, M kali dengan G. G 9.8, mass ialah yang kamu sebut tadi. So the 75 kilogram or 60 kilogram is a mass. Okay. And okay, so this is what happened in the lift. Okay, when you are in the lift or in the elevator, when the elevator is accelerating upwards, meaning that the elevator is going up. Okay, going up. then the positions of elevator is going up, meaning that okay, the elevator is naik ke atas, okay, and of course the weight, our weight is based on the gravity, and the gravity always works towards the center of the earth. So kalau kita dekat mana-mana pun di atas bumi ni, kita punya weight akan sentiasa ke bawah. It's always pointing to the center of the earth. Okay, jadi kita boleh bayangkan, okay, the gravity that we are using is the gravity of the earth gravity, meaning that the value should be equivalent to 9.8 meter per second square. And of course, it's going straight downwards. Okay, straight downwards meaning straight to the center of the earth. And how about WA? Okay, that is called apparent weight. This is the weight that's actually we are trying to use that thing in terms of the terms apparent weight. Apparent weight is not your um, it's not your uh, a true weight of you. Okay, apparent weight can change. It can be changed because it should follows the accelerations. Okay, it should follow the acceleration. If the weight, if the apparent weight, okay, you can look at the equations here, that the WA, okay, which is going upwards, minus with W is your own weight, well, which is going downwards, will equivalent to MA. Okay, this part, okay, is F, meaning that the weight is a part of force. Okay, don't try to differentiate between weight and force because it uses the same unit, Newton. Okay, force and weight share the same units. Okay, so therefore we can say that weight is actually part of the force, right? And will equivalent to MA. And what is mass? Mass is your own mass. Okay, this person's mass times with A. Okay, A is the accelerations of the lift, okay, or the elevator. So that's why we'll try to do it later. So we can say that then, of course, you can bring this weight to this side, okay, because you want to know what is your apparent weight. Okay, your weight is always mg. Okay, weight is equivalent to mg, while apparent weight will change. Why? In this case, in the case of the when the elevator is accelerated upwards, then your apparent weight is equivalent to your mass, okay, times with the acceleration of the lift of the elevator times with the gravity. Sorry, plus with the gravity. So the product of A plus G you times with M, then you can get apparent weight. So definitely your apparent weight should be higher or lower. Okay, obviously it should be heavier than, your weight. Okay, so because of WA should be because of, let's say if your weight is 40 or 10, and just make a few good examples. Let's say the acceleration is 10 and the gravity is also 10. So 20 times with 40, let's say your weight is 50, okay? 20 times 50, so you will get 1,000, okay, 1,000 Newton. While for your weight only, so if you just M times with G, so your M is 50 times with the G is 10, so it's just 500. Okay, so 500 and 1,000 you can look. So we can actually say the apparent weight is heavier than your weight. Okay, so that is why we call it as apparent weight. So apparent weight is a perception of weight, not the real or the true weight. Okay. Anyone have a questions that you can ask? Just ask me. Okay, no problem. You can stop me. Okay, so this is the Newton's laws of motion. So the first law is the one that related to the inertia. Okay, you always say that the first law is always inertia. It doesn't do that way. Okay, because the first law stating that an object at rest will remain at rest, and if the object is in motion, and it will always move until you have force that can stop that motions. Okay, so that is how you explain the Newton's first laws. While for the second law is the rate of change of momentum of an object with time. Okay, because it is directly proportional to the net force, meaning that the product of mass times with acceleration is equivalent to a total F. Total F or submissions of F, meaning that there is not only single force on the left side. Okay, when you try to deal with or you try to imagine the situation, okay, it doesn't only involve one force. Okay, it will always we should consider, okay, we should consider a lot of forces should be put into the on the left side. Okay, because that is as how they write the submission of F kan, ada tanda E macam ni, yang E besar ni. Okay, so ini yang dikatakan sebagai submission. Submission ni ialah hasil tambah F. Hasil tambah F, masa kena faham, every forces must be add. But you must remember also that force that acting on against the directions of other force should be minus. Okay, so that's why adanya ada tambah tolak. Sebenarnya semua force kena tambah. Okay, tetapi bila adanya negatif, how can we get negative? Because of the directions of other force is against each other. Okay, so that will be the Newton's second law, the first law and second law. Okay, and of course, when you try to write down the Newton's second law, please consider that this is a submission of F, a total F. Okay, but you must spread or you must divide it into submission of Fx and of course submission of Fy. Meaning that you should differentiate between Fy, which means all total force in y-axis, okay, with the total force in x-axis. So that's why we need to emphasize on this part of the equations. Okay, so this is the second law of motions. Okay, so another thing is that the video said about the importance of drawing a free body diagram, what we call the FBD. What is free body diagram? Okay, so let's look at the free body diagram over here. Okay, so this is the free body diagram. Okay, let's look at the problems. When you have this is actually a motorboat or sampan or whatever, it being pulled by person A and person B. Okay, maksudnya ada person yang A dan B menarik motorboat ataupun sampan ini ke hadapan. Dia akan tarik je ikut arah force yang the directions of force given in the figures. Okay, so person A have a 45 degrees. Okay, first person B pull this motorboat in the 37 degree along x-axis. Okay, along x-axis, meaning that okay, it should be pulling using this kind of angle. And of course, A and B doesn't have the same force. Okay, meaning that the total force A is 40 while for B is 30 newtons. So definitely for A is much higher compared to B. Okay, not really high, but we have a 10 newtons difference. All right. So you must do whatever we can when you deal with force. Okay, first you must resolve the forces into its component. That's why in the second figure you can see here from FA. FA means the force for person A. Okay, have been divided into FAX, meaning that the force in the x-axis, and FAY, the forces in the y-axis. And that is also what we do in FB, meaning that force for person B. So we actually divide it into FBX and FBY. And of course, all the AY now we can add with the BY, and AX we add with the BX in order for us to get the magnitude of force. So again, when we try, first layer of how to solve the forces is you must draw. Okay, draw your own. If the question doesn't instruct you to draw or to sketch a free body diagram, you do it on your own. Okay, buat sendiri. Buat kat mana, buat kat tempat lain lah. Okay, nak buat dekat dalam soalan pun doesn't matter, because sometimes, okay, remember, sometimes, okay, when you stuck So you always have to look back to the questions, and try to demonstrate or try to sketch back, okay, the free body diagrams. So maybe you may found the problem. Maybe it's either during resolving the components, okay, masa nak resolve component tu, tiba-tiba salah, tekan calculator dan sebagainya. So that's how you can check your answers. Always can check your answers. Okay. All right, so the same things you can apply in the components, okay? So this is the good examples of find the accelerations of the car. You may see this is the car we are talking now, and of course, he have been pushed with the 275. Look at the direction. Look at the arrow of 275. The arrow is going to the right. Okay, and of course, when you draw a free body diagram, your arrow should be pointing out from the Cartesian coordinates. Okay, so that if that tries to imagine that the x and y axis is a Cartesian coordinate, your imaginary Cartesian coordinate. So just put ada asalan over here, the 0, 0 coordinates. So when you look at the figure of the car, okay, so this person is actually pushing the car at the back of the car. Okay, but how come then these two persons, 275 and 395, now have a force that going to the right at this very dark point over here? Okay, so that's how it means by the free body diagram. So free body diagram kita buat dekat tengah-tengah. Maksud dia dekat mana? Dekat tengah-tengah kereta ni. Tetapi kita bila kita lukis free body diagram, it should be going out from the point, going out daripada point hitam. Itu masuk free body diagram. The true free body diagram is and then arrow should be pointing out. So remember, if you are pushing anything, make sure this arrow should be put here. Okay, arrow tu akan diletakkan di kanan, bukan di sebelah kiri. Tapi tengok and of course the opposing force, okay, maybe it's due to the friction or whatever, and that equivalent to 560 is going the other way. Because why? Because maybe because of the questions, right? But that's how when you look at these equations, 275 plus 395 minus 560 will equivalent to plus 110 Newton. Okay, so this all happen in x-axis. It doesn't involve y-axis, so we don't need to do y-axis. Okay, it is not compulsory to use fx and fy simultaneously. So we should look at the different cases. Different cases maybe give you different view. So that's why, okay, try to look at the situation. If the situation only involve x-axis, then you don't need y-axis. Because obviously the car and the persons that are pushing the car doesn't floating. Dia tidak naik, dia tidak terbang ke atas. Bila ada terbang ke atas, barulah kita boleh katakan that this have y. Tapi disebabkan ini, dia hanya ada x. Okay, sebab dia hanya moving ke kanan dan ada satu opposing force ke arah kiri. Okay, it's only involve x-axis. Boleh faham semua orang? Anyone?
Boleh saya.
Boleh ya? Okay, alhamdulillah. Right? So that's why when you deal with something related to Newton's second law, always remember, okay, at your level, okay, you will be divided into y and x. Y stands for, okay, forces in y-axis, while for x is the total forces in x-axis. For example, our previous examples is using x-axis, and it doesn't use y-axis. So we don't need to calculate anything in y-axis because it doesn't have y-axis at that particular questions. Okay. So ada soalan boleh guna dua-dua, ada soalan boleh guna y saja, ada soalan boleh guna x. Okay. Alright, so the normal forces and the kinetic friction forces. Okay, so what is the normal force? Well, normal force, Okay. A reaction force exerted by surface. Maksud dia dekat mana? Okay, reaction force ni. Reaction force ialah ini. Maksud dia, okay, try to remember the Newton's third law. Newton's third law saying that whatever you give, you will get the same value. Okay, so let's say, okay, now, okay, when you put some objects on the table, definitely that object will have mass because it's an object. Okay, balon pun kalau walaupun dia nipis, tapi bila kita letakkan angin dalam balon, so dia akan ada mass. And that mass is going straight downward. Nampak ni, W ni direction dia straight downward. Okay, you already know because W is equivalent to mg. And there will be other forces that acted, okay, against the directions of the weight, which means we call that as reaction force, or we in the correct way we call it as normal force. Okay, normal force ni always perpendicular to the surface. Ingat, always perpendicular. Where is the surface? Here is the surface. Floor is the surface. So 90 degrees for the surface or for the floor, 90 degrees of the floor is normal force. Okay. And how about friction? So friction always oppose the motions, the directions of motion. Let's say if you are going to the right, your friction should be going to the left. And if you are going to the left, your friction should be going to the right. If you are going upward, then your friction should be going downward. But everything must be in place. When you're trying to deal with friction, make sure it must have a surface. Kena di atas, maksud dia bila nak guna frictional force, okay, kalau air friction itu lain, maksud dia rintangan udara itu lain. Biasanya dalam kes yang kita melibatkan kelajuan, kita akan gunakan air friction. And always air friction is negligible because it's quite small value. Okay, but biasanya kita akan lebih kepada contoh, okay, a smooth inclined surface. So meaning that there is no friction. Itu selalu digunakan ayat. Okay, a smooth inclined surface. Yes.
Yang coefficient tu macam mana tadi sir?
Yang mana satu?
Coefficient of friction tu.
Coefficient of friction belum masuk lagi. Saya baru cerita pasal friction force.
Oh yeah, okay.
Okay. For friction force, mau nak cerita pasal F. And normally we use a small letter F. Okay, friction kita pakai small letter F, kita pakai F kecil. Nak bezakan dengan force. Ya, tu nampak ya. And tengok force is going to the right and frictional force against F tadi. Kenapa against F tadi? Suka-suka dia ke? Tak. Because it's always opposed, melawan arah motion. So kalau ada pergerakan ke kanan, dia nak lawan kiri. And what is frictional force? Okay, so the equations of the frictional force is F equivalent to mu n. What is mu? Coefficient of friction. There are two coefficients of friction. Satu dia ada kinetic coefficients of kinetic friction. Satu lagi kita ada coefficients of static friction. Dia ada mu k dengan mu s. Tapi formula dia tetap F equivalent to mu kali dengan n. So mu tu tak kisahlah mu k ataupun mu s. Contoh dia saya boleh gambarkan dekat sini semua boleh tengok saya kan? Okay. Bayangkan ini ialah okay, macam mana saya ada satu nampak tak? Okay. Macam ni. So ini dikatakan friction. Okay. Tapi bila kita tolak macam ni, maksud dia kalau tengok, okay, sebelum dia mula bergerak ke bawah, dia akan stay pada satu tempat. Okay. Dia akan stay dulu. Maksud dia ringan sakit. Okay, dia akan stay pada satu tempat. Like this. Okay. So you can see the calculator is actually at the be put on the surface. Okay, meaning that the calculator will have a weight going towards the center of the earth, And you must have pada masa yang sama dia ada N. Okay, which is what we call as normal force. Okay, apa yang berlaku kalau saya inclinekan dia? Saya apa masih incline, saya cuba condongkan dia. Bila condong, okay, nampak tak? Sepatutnya kalkulator ni akan jatuh. Tapi pada masa ini, nampak kalkulator ni ditahan daripada jatuh. Kenapa dia boleh ditahan daripada jatuh? Sebab dia ada friction. Tetapi pada masa yang sama, bila dia dah mula jatuh, dia akan terus jalan ke bawah. So maksud dia pada masa itu kita ada dua jenis friction. Okay, kita ada kinetic friction dan static friction. Static friction bila dia duduk diam. Kinetic friction, friction semasa motion berlaku. Maksudnya kan kalau kita berjalan, kita jalan, macam mana kita jalan dengan ada friction force. Tapi friction ni jenis apa? Jenis kinetic motions. Okay, kinetic tu apa perkataan masuk kinetic? Kinetic tu ialah pergerakan. Okay, static pula, static ialah maksud dia duduk diam, pegun. Kan, objek dalam keadaan pegun, dalam keadaan duduk diam. So that's why, okay, tidak ada pergerakan. Tetapi pada masa dua-dua ada friction. Okay. Ada soalan? Amirul, boleh ya?
Boleh sir.
Okay. So this is the numbers. Okay, look at the next, which is the tension. Okay, tension is always related to rope or any cable that can be connected between two objects or whatever. And of course, you must understand this one thing. Okay. When you do have okay, when you do have one object, okay, and have been connected into another object like this, remember one thing, that this, okay, there will be a tension. Okay, by looking at the rope or cable that connecting the objects. And yang paling penting sekali ialah dekat mana directions dia. Okay, what will be the directions of the tension? Kan, sama ada ke sebelah sini ke ataupun andul. Okay, ataupun sebelah sini ke. Okay, yang mana satu yang sesuai objek. Tapi untuk objek yang ada kabel lah, connecting between the object, sebenarnya arah dia ialah macam ni. Satu sini, satu sini. There will be towards each other. So kalau ini ialah kabel yang sama, jadi dia punya T tu satu T sini, satu T dekat sini. So ada dua nilai T yang sama, ada dua directions of T, tetapi nilai T tu ialah nilai yang sama. So this is what we call as Newton's third law. Ni Newton's third law. Okay, so remember those things, right? Okay, so in this case, kalau bayangkan bila kita letakkan dia, ni objek yang tadi tu, kita letakkan dia pada puli. Ni puli nama dia. Okay, puli ni kebiasaannya kita akan mention is a mass, should be massless. Maksudnya kita tak akan kira puli ni punya motions, kita tak akan kira rope ataupun kabel ni punya motions. So maksudnya kabel ni semua mesti massless, seolah-olah macam benang, macam tak ada nilai weight langsung yang akan kacau dia. So kita boleh concentrate directly kepada ni. So macam mana nak lukis free body diagram dia? Obviously dia akan ada satu mg, tapi mg apa? M1g lah. Okay, ada T1 ke atas, dan lagi yang belah sini dia akan ada M2G. Itu cara tulis dia. Okay, ada tak normal force dalam ni? Anyone? Ada normal force tak dalam ni? Agak-agak. Ada tak normal force? What do you think? Is there any normal force in this case?
Tak ada, Ustaz.
Ifan kata tak ada.
Kenapa tak ada? Kan?
Sebab dia tension antara dua rope. So
Okay.
consider normal force tu as tension T1 and T2
Okay.
upwards.
Okay. Okay, thank you Irfan. Normal force hanya akan berlaku, normal force hanya akan berlaku jika jika ada jika ada permukaan. Sedangkan dalam keadaan ini, mana ada permukaan? Kotak ni duduk tergantung dengan kabel tu. So tidak ada end dalam ni. Yang ada hanyalah tension. Because of what? Because of the existence of cable ataupun rope. So that's why dalam kes ini no normal force. Tak ada normal force. Okay, adalah nanti situation kita akan tengok macam mana. And of course T1 is equivalent. Ya?
Dekat puli tu tak ada ke sir?
Dekat puli ni pun tak ada. Sebab tu dekat puli ni akan ada kalau kita belajar dalam next topic, which is topik yang dinamakan dynamics equilibrium. Maksudnya itu nanti kita akan
Sir.
tahu. Yes.
Normal force ada bila untuk objek pegun je kan?
Objek yes. Boleh kata macam tu. Cuma dia normal force ni objek pegun atau tidak, dia depends kepada surface dia. Maksudnya kalau dalam pergerakan, dalam motions, selagi kita boleh tangkap gambar, maksudnya kalau motion biasanya kita nak buat soalan takkanlah kita tak boleh tangkap gambar kan. Maksudnya kita boleh tangkap gambar tu walaupun dia kata acceleration going downwards. Contoh dia macam dalam kes saya cuba cuba tengok ni Okay, walaupun dalam keadaan incline maksud dia, apa maksud incline ni? Maksud dia definitely dia akan jatuh lah kan. Kalau dalam kes ni definitely dia akan jatuh. Okay, macam mana pula ni? Going down kan, obviously dia punya acceleration boleh jadi juga dia naik ke atas. So walau dalam kedua-dua keadaan ini acceleration normal force masih ada. Itu masalah jawapan saya itu, normal force tetap akan ada dalam kedua-dua keadaan. Walaupun dia dalam pegun, okay, ni contoh pegun yang ni lah kan, ataupun dalam keadaan dia dalam pergerakan, tetap ada normal force as long as objek itu masih lagi berjalan ataupun duduk di atas surface. Okay? Boleh ya?
Boleh.
Okay, so kalau kamu tengok dekat sini, there are the different types of force. So you may find that this is a gravitational force, okay, that due to the weight, and of course the reaction force on a normal force. Ini tadilah kita boleh nampak dalam beberapa keadaan. This one is the free body diagram in the plane surface. This one for the inclined surface. Inclined surface ni satu benda yang kalau dulu masa sekolah dia jinx lah. Kan? Dia jadi macam alamak, macam mana ni nak solve problem ni. Tapi sebenarnya senang kalau kita boleh faham force. Maksud dia faham macam mana nak calculate, macam mana nak lukis nak lukis or how to draw the free body diagram. Okay, and of course dalam keadaan ini you must very master dalam menentukan components of vector. Okay, contoh dia kalau macam ni kan, macam mana dia boleh dapat mg sin theta, mg cos theta. Okay, sebenarnya for those yang rasa keliru dan sebagainya, it's actually because of this force. Okay, force mg is going this way. Kenapa going this way? Obviously sebab dia mg, dia ialah weight. Weight is going straight downward. Dia tidak akan sengit, tidak akan macam-macam mana pun. Tetapi normal force kalau kamu tengok, dia mesti duduk macam ni. Dia sebab dia follow surface. Surface kalau dia ada, dia mesti perpendicular, dia mesti 90 darjah dengan surface. So that's why dia duduk dalam keadaan macam tu. So normal force tidak tetap pendirian, dia akan berubah-ubah. Tetapi kalau weight is always going straight downwards, dia akan straight ke bawah tanpa ada sengit. Okay, so because of weight is considered as vector atau considered sebagai force, jadi mesti ada komponen. Macam mana nak determine komponen dia? Adakah satu komponen Y dekat sini atau satu lagi X ni kat atas ni? Pelik lah kan? Sebab kalau macam tu, mestilah weight dia ke sini baru dapat. So definitely bukan yang tu lah. Okay. Sebab tu lah satunya ialah yang ke bawah. So yang ni. Dan satu lagi ke sebelah sini. Barulah dua-dua ni menghasilkan force yang tengah-tengah ni. Okay. And definitely for the inclined surface, remember, inclined surface duduk dekat sini. Theta dia. Mana satu theta yang sepatutnya yang sama. So macam mana kita kadang-kadang soalan dia tak bagi straight macam ni tau. Okay, soalan biasanya dia bagi kotak ni, dia bagi incline, dia tak tulis kat sini ada theta dekat sini. So kita kena determine belah mana theta dia. So biasanya theta memang duduk di antara vektor, memang selalunya vektor dan juga y, paksi y. So disebabkan paksi y, angle this angle is in between the vector and the y-axis. So yang y lah akan jadi mg cos theta. While for the other one that is going this way should be equivalent to mg sin theta. So inilah yang akan digunakan bila kita nak masukkan ke dalam submission of fx dengan submission of fy. Oh, teruknya. Okay, submission of fx and submission of fy. And definitely, kalau kita tengok situation ni, pergerakan dia hanya pada arah x. Maksudnya pada arah kotak ni hanya akan bergerak di atas inclined surface ni. Sama ada dia naik atas ke bawah ke. It's always on the x plane, on the x-axis punya plane. So that's why fx equals to ma. And ada tak awak nampak kotak ni melayang ke atas atau masuk ke dalam ni? Tak. That's why fy dia equals to 0 because acceleration 0, so fy equals to 0. Itu yang selalu terjadi bila kita nak solvekan inclined surface. Okay. And of course, the other one is the frictional surface. As I mentioned to you, you have a static. Okay, F kali dengan F and mu S, which means the static coefficients of friction, and times with the normal force. And F, okay, is equivalent to mu K, which means the coefficients of kinetic friction times N. Okay, mu K dengan mu S. Definitely biasanya dalam soalan, and the question will ask you maybe to get the answers mu K or mu S, or it's already given inside the questions. So mu K dengan mu S tak perlu hafal because every material have his own mu K dengan mu S. So you don't have to bother to memorize all the mu K and mu S inside your textbook. Okay, definitely you just consider that thing. If anything else, katalah dalam soalan pun tak bagi, appendix pun tak bagi, then what you can do is just leave your answers in a mu K and mu S punya term sahaja. Itu je. That's how you can do. Okay, ada soalan? Ada?
Saya. Yang
Yes.
tension tadi tu kan, kalau tak kena surface kan tak ada normal force kan. Lepas tu kalau salah satu kotak tu kena surface, ada normal force tak?
Katakanlah kotak ni macam mana biasanya dalam kes sekarang ni ini kita consider T1 memang duduk atas angin lah. T2 pun kita consider duduk atas angin juga. So kalau katakanlah cerita dia sekarang dia dah sampai bawah. Dia sampai bawah. Kata dia sampai bawah. Yes, ada mg. Okay. Ada n. Kata dia dah sampai bawah. Tetap ada N. Tapi tak logik lah untuk ada T2 ni. So cerita dia kan. Sebab macam mana dia nak tarik, macam mana T2 dengan T1 ni pula kan. T2 dan T1 ni mesti sama value dia. Sedangkan T2 tadi tak sampai lagi. T2 tak ada kaitan dengan ground. Itu soalan saya, jawapan saya lah.
Thank you lah.
Lagi? Okay. Ada questions? Ada?
No sir.
Okay, so kita continue tengok video, next video
Assalamualaikum and very good day to all of you. Okay, let's proceed with the next part of chapter 4 after you have learned all about Newton's law. These are the units for chapter 4: kinetic friction forces, static friction forces, tension forces, and applications of Newton's law. Okay, for this chapter or for these topics, these are your learning outcomes. At the end of the lesson, you should be able to cover point 1 until point 5. I think you can read it from here. Okay, let's move on to the next slide. Frictional forces. Okay, friction has its basis in surfaces that are not completely smooth. It's actually a resistance between an object and also a surface. So when an object is in motion, there will be a resistance to that motion. It's actually due to the interactions between the object and its environment. And this resistance is called friction. Okay, friction is not always impedes the motion. Okay, without friction, we wouldn't be able to walk or hold objects or pick up objects. Okay, there is a force called the kinetic friction force acts when the object is in motion. When an object that is in motion, look at this one, the force is to the right and there is an opposing force called kinetic friction force. And this is the equations of the kinetic friction force. Fk equals to mu kn. N is the normal force of the object. Mu k is the coefficient of kinetic friction. Fk is the kinetic friction. Okay. Fk arises during motion and it depends on the material of the surface. It shows how smooth or how firmly they are in contact. Okay, normal force here is the measure of that firmness of the contact between the object and also the surface. So from this equation, you can see the relationship that the higher is the normal force and the kinetic friction will be higher. Okay, next. Okay, just like it was kinetic friction force, which acts on an object which is moving. As for static friction force, it's a force acts to keep the object from moving. Meaning object doesn't move unless the applied force exceeds some critical value. And this critical value is a maximum static friction force. In meaning over here. So if you can see this one, the trash can over here, you can see all the forces that acted on this trash can. You have the applied force, the static friction force, and you know you have normal and the weight of the trash can. Now, this trash can is not moving, it's statically sitting there, okay? And you applied force, that is, this trash can is being pulled over here. And then you keep on exerting the force, adding the force, and it's still not moving up to a point you have enough force and it starts to move. And that's when, before it starts to move, that is the maximum static friction force. Because after when the trash can starts to move, it has become kinetic friction force. Later I'll show you the whole graph for it. Okay, so as you can see from the graph here, when you increasing the force, you also increasing the static friction force, but up to a certain maximum point, which is the maximum static friction force. Because when the trash can starts to move, that's when it becomes kinetic friction force, meaning right over here, the kinetic region. Okay, this is the whole graph of these two trash cans. I mean, one trash can. First, it wasn't moving. Next, it's moving. So it was steadily sitting there, and then you keep pulling this trash can. You keep on pulling and pulling, but it doesn't move. Up to the point, yes, it moved and starts to move. That's when you have the kinetic friction force. This one, the Fk equals to mu Kn. Okay, so this one is the static region. This is the kinetic region. As for that, you can see the difference between kinetic friction force and also static friction force. With that, you will see that the friction is proportional to the normal force. So F is proportional to the normal force. And static friction is greater than kinetic friction. As you can see from the graph, you will see that static friction is bigger than the kinetic friction. Okay, coefficient of friction, either it will be coefficient of kinetic coefficient or static coefficient. It must depends on the surfaces of the contact, meaning the different material are going to have different mu or different coefficient. Okay, direction of the frictional force is always opposite direction of the motion or direction of the applied force. And coefficients of friction are nearly independent of the surface area of the contact. It doesn't matter how big is the area, it doesn't really bother the coefficients of it. It's just the material or maybe what type of surface it is. Okay, kinetic frictional force independent of the speed and also its area of contact. Like I told you just now, it doesn't depend on the area of the contact. It only depends on the contact, the material of the contact, the surfaces. So just look at this diagram here. It's a very simple experiment showing a block is being pulled by a spring scale. So it's being pulled by a force here and it's moving. Then you're going to have the kinetic frictional force. And what happens when you add another block on top of it? When you add another block, so the normal is going to be increasing. Thus, your kinetic friction also increasing. As for that, you need to apply more force. So adding second brake doubles the normal force, which doubles the kinetic friction, right? Okay, this is the relationship that I'm meaning to show you just now. So the friction experienced by surfaces sliding against one another. So unit motion equals without saying because it's kinetic. Alright. By this relationship, you see the summation of Fx is ma. So you learn this in Newton's second law. So F minus Fk equals to 0 because velocity is constant, so there is no acceleration. Thus, your force equals to the kinetic frictional force. The kinetic frictional force is proportional to the normal of the object. Okay, mu k is coefficient of the kinetic frictional force, and static frictional force depends on the normal force of the object. Okay, look at these some coefficients of friction, the table of coefficients of friction. So they give you the mu s and the mu k. Mu s is coefficients of static friction and mu k is coefficients of kinetic friction. So steel on steel is 0.74 and this one is 0.57. You can see that mu s is bigger than mu k. Static friction is bigger than kinetic friction. It makes sense though. Give you one example. If you are running and compared to you just standing without doing anything, it's easier to push you when you are running because you are it's so easy to push you when you are running than rather you are just standing because you need more to apply more force than someone that is already running. So it's easier to push someone that is running and rather than someone just standing. So that's the logic of it. Okay, so just bear in mind that static friction is bigger than kinetic friction. So does the coefficients of static friction and coefficients of kinetic friction. Okay, let's look at this example of the sliding hockey puck. All right. Given to you this hockey puck in this diagram with initial speed 20 meters per second. The puck remains on the ice and slides 120 meters, slowing down steadily until it comes to rest. So there is a keyword here. Okay. Determine the coefficients of kinetic friction between the puck and the ice. Okay, how to do this? Okay. Okay, I always like to extract all the information given. So you know that 20 meters per second is the initial speed. So this is your V naught. Okay, it's like, oh, I'm so sorry. It's like 120 meters. So this is your delta x, slowing down steadily until it comes to rest. That means the final velocity is 0. And the question asking for coefficients of kinetic friction, meaning the mu. Okay, I'm sorry, my handwriting is just terrible. Okay, let's look at how you have to do this, and let's look at the solution. Okay, first thing first, you have to draw the free body diagram. So you can see here it's moving to the right. So this is the motion, and as you know, kinetic friction is always opposing the motion. So this is the direction of the Fk. You got the normal and the weight of the hockey puck. So what you have to do next, extract the information given. I already extracted for you. Okay, so you have V naught is 20 meters per second, the delta is 120 meters, the V, the final velocity is 0, and what is the coefficients of kinetic friction? So first thing first, what you have to do, you need to find the acceleration. Okay, by using this kinematics equation, motion, okay, you extract all the information, then you just substitute the values inside here, then this is what you get. The acceleration is negative 1.67 meter per second square. And after you have found the acceleration, then you need to find the normal force. So normal force here is equivalent to the weight of the hockey puck. Alright. Substitute n equals to mg into the equations of this one. Fk equals to mu kn. So you're going to get Fk equals to mu k mg. Okay. And you apply into this equation because the motion in x direction. So Fx equals to ma. You apply into the Newton's second law. So you're going to get this one, negative Fk equals to mu k mg. Just substitute all the values inside here, and this is your mu k 0.170. Okay, there are other types of friction. Okay, the friction between the moving car's wheels and the road is the static friction. We also have air resistance that we experience, and also fluid friction. This is actually happened experienced by ships or passage of a fluid in pipes. Okay, so those are the types of friction. Okay, we're done with the friction. Now is the applications of Newton's law. Okay, things that we need to assume means object behave as particles. We can ignore the rotational motion for now. You're going to learn about rotational motion soon. Okay, masses of strings or ropes are negligible. Interested only in the forces acting on the object, and we can neglect the reaction force. You know about reaction force. We can neglect that at the moment. Okay. Okay, tension forces that's usually experienced in the rope. Okay, you need to ignore the frictional effects on the rope, ignore the mass of the rope, and magnitude of the force exerted along the rope is called tension. So when you pull a string or rope or cable, that one we call as tension. We call force. It's a force, but the name of that force is tension. Okay, the tension is the same at all points here on the rope, right? Now we want to see these are the example. Like this boy is pulling a cart, a big cart with a rope that is attached to it. Magnitude of the force, tension T acting on the bob. Tension is the same at all points along the rope. So you have the normal and also the weight are the forces exerted by the earth and the ground of this card. Okay.
Okay. So the next video is explaining about the topics of frictional force. Okay, so you may look at the points where the usage of mu s and also mu k. Okay, is mu. Mu means coefficients, meaning that it is a value that has its own specialized on the materials. So every material has its own mu. Okay, so either it's mu s or mu k depending on the situations. Okay, like I'm saying now, it's all about situations. Okay, so we want to jump to the next video. So let's look at the next video while I'm explaining.
Okay, next one is equilibrium. What is equilibrium? An object either at rest or moving with a constant velocity is said to be equilibrium. At rest meaning it's not moving, being at rest. Constant velocity means it's moving but it's not accelerating. So total force or net force acting on that object is zero. Okay, this is when object is at equilibrium. Okay. As for equilibrium, the object is at rest or not accelerating. It's easier to work with the equation in terms of its component. So total force or net force acting on object is equal to zero. So you have to take it into account its forces that acted on x direction or y direction. So right here, when its object is at rest, total force in fx and total force in y direction is also zero. And this also could be extended to 3 dimensions. We have x, y, and one is z. Okay. A zero net force does not mean the object is not moving, but it is not accelerating, like I told you just now. Okay. Okay. These are one of the examples of equilibrium, meaning traffic light hanging by 3 cables. Okay. Can we just put an example? Okay, this is the question. Traffic light weighing 100 Newton hangs from a vertical cable. So this is the cable and 2 other cables that are fastened to a support. So this is the support with angles 37 and 53 degree. Find the tension in each of the 3 cables. So the question asking for what is the tension in T1, cable 1, T2 and T3. So yes. First thing first, draw the free body diagram like this. Then you know where is the directions of each component in x or y direction. Okay, so this is me. So okay, so again, so T3 is pointing upward and the weight is down for this part, and you have T2, T1, and T3. Okay. Always need to draw the free body diagram so you know where are the directions of each component. After you have found that, I think you can easily solve for T3 over here. Then you get this one. Total Fy over here. Total Fy equals to 0. Why? Because it's in equilibrium. Thus you get T3 minus the weight equals to 0. Then you get T3 equals to 100 Newton. So solve for T3. How to get the T1? You can draw this table here and categorize for each of the force, the x component and y component. So T1 is the x component will be where? This way. The x component of T1 is this way. T1x. So your T1x is negative T1 cos 37. And for its y direction is this way. T1y, which is T1 sine 37. How about T2? T2, the x direction is this way. T2x. The y direction, the y component, sorry, is T2 to y. Now with that, you can see the arrows here, right? Okay, the T3 is downwards. Okay, so now you look up according to its axis. Okay, now first is the in x direction. No, in x axis you have, where is the x axis? This way. So, oh sorry, all the forces acting in x axis are T1x and also T2x. Okay, you just take the value from here. You see T1 cos 37 is over next negative direction, plus with the T2 cos 53 you get 0. Then what are the forces in y direction? These are the forces in y direction. So you have T1y, T1y over here, T2y over here, and minus whatever is downwards or negative side with the weight equals to 0. When you have found this, you can now solve the simultaneous equation. Okay, very easy. Okay. Okay, next example of equilibrium is object on inclined planes, like this light being tied up to a tree. Okay, it's in equilibrium. Okay, let's just proceed with the example. Okay, in dealing with object on inclined planes, you need to see that normal force is always perpendicular to the surface. Always have to take the normal that perpendicular to the surface, because look at the axis of x and y is being tilted, it's being inclined. Okay. Alright, one thing, it's a small mathematics. When you have object is on inclined plane, when you see the theta here, let's say the theta is 30, the theta over here also the same. It's 30. It's being proved by this geometry here. Okay, so this is being inclined on theta. So this theta and this theta is just the same. So the x component for this weight is over here, w sine theta, and the y component for this one is w cos theta. Alright. Okay, the example just now. Okay, here showing a sled is tied to a tree on frictionless snow-covered hill. If the sled weighs 77 Newton, find the magnitude of the tension force of the rope on the sled and the normal force exerted by the heel on the sled. So first thing first, what you have to do is draw free body diagram. Okay, first thing first, always draw the free body diagram so you can see all the forces acted on that sled. Tension is over this side, x direction. Okay, and you have the normal in y direction. The weight, how is the weight? Weight, you always need to draw from the objects, just pull it down like this. Okay, then you see that weight actually has component. Its component is in y component and also x component, because your axis has become like this. This is in y direction, this is x direction, and upper that is y direction. Okay, so please solve according to its axis. So for fx, what are the forces involved in x direction? X, this one you have tension, you need to minus with the mg sine theta. Okay, and you just substitute all the value inside and then you get the tension. Next, the question asking for the normal. So for the normal force of the object, look at all the forces acted on y direction. So you have n, okay, and you need to minus with the mg cos theta, substitute all the value, then you get the answer for normal force. Alright. Okay. Okay, another example for object on inclined plane is this one. The question asking for what? Okay, let's read the question. A car of mass m is on an icy driveway inclined at angle theta 20 degree as the figure shows. Determine the acceleration of the car assuming the incline is frictionless. So you need to find the A acceleration. Okay, finding the A, and then you need to find if the length of the driveway is 25 meter and the car starts from rest at the top, how long does it take to travel to the bottom, and see what is the car speed at the bottom. There are so many questions, then you have to do step by step. Okay, first thing first, always draw the free body diagram. So this dot is the car. Okay, normal force acted in y direction, and the weight is always pointing downwards here. Okay, weight of the car. Then you see the weight has its component over here and over here, the mg sine theta and also mg cos theta. So this is x direction, this is y direction. Okay, x and y direction. Okay, so you need to solve it. The first thing first, they ask for the acceleration. How to find the acceleration? So you have to use the Newton second law. Okay, ma equals to the total force that acted on x direction, meaning here this way. So we have max equals to, what are the forces acting on x direction? Only this one, mg sine theta. Okay, and for y direction, what are the forces acted on y? N minus mg cos theta. So these are the forces that acted on y. So you have first equation and second equation. Then you can find ax, okay, by just substituting all the information or all the values that has given to you. They ask you to find the delta x. Okay, when you have found the acceleration, you can use the kinematics equation to find the delta x. Okay, very easy this one. And lastly, they ask you to find the speed. When you have found the time over here, you can use the equation from kinematics to get the speed. Okay. Alright, let's look at I think one last example for inclined planes, toboggan to the bottom. So this thing we call toboggan. Okay, a child of mass m rides a toboggan down a slick, ice-covered hill, inclined at angle theta with respect to the horizontal. What is the acceleration of the child, and what is the normal force exerted on the child by the toboggan? They didn't give you any value, so we just need to work out with the formulas, the equation. Okay, like the usual, you should draw the free body diagram first and look at all the forces that acted in x and y direction, in x and y direction, in x and y direction. Okay. Alright, they ask you to find acceleration. Okay, look, acceleration is obviously this way. Okay, so it's an x direction. So what are the forces acted on x direction? Is this one, w sine theta is equals to mg sine theta equals to the ma. You need to apply the Newton second law. Alright, next they ask you to find the normal of the force. So normal is this way, the y direction. So we have n equals to mg cos theta, negative mg cos theta. Over here is n equals to mg cos theta because n minus mg cos theta equals to 0 by applying the Newton second law. So you get A and also the normal. Alright, let's move on from inclined planes to multiple objects, another application of Newton's second law. So when you have more than one object, the problem solving strategy is applied to each object. First thing first, always we need to draw the free body diagram for each object, then apply Newton's law to each object and solve the equation. Okay. Example. Okay, this one of the example of multiple objects, the Atwood machine. So you see you have two objects, right? M1 and M2. So always work separately first. Okay, then you see M1, you can see the tension is upward, the weight is downward. So this is T and this is mg. Okay, same goes to the M2, tension is upward and the weight is downward. Always draw the free body diagram. Okay, in multiple object, we will learn about the apparent weight. Apparent weight that we feel when we are riding the elevator or in a lift or on a lift. Okay, so when elevator accelerating upward, we feel heavier. When elevator accelerating downward, we feel lighter. I think you know this. You experience this yourself. Maybe you just don't bother whether you feel heavier or lighter, but it is true. You can try for yourself when you are riding the elevator. All right. So how come? Like this. Okay, by applying the Newton's second law, you will see total force that in y direction equals to ma. So the apparent weight is the tension of the cable of the lift actually. That is the apparent weight that you feel. It's minus the of your weight downward is equals to ma. Then thus we get your apparent weight is ma plus the weight. And you get this one, m equals to a plus g. That's why you feel heavier because because your weight or your mass is multiplied with additional of the g. G is the gravitational acceleration. Right? Let's get the example.
Okay, so that will be the applications of the forces. So in this case, it includes the how the problems solved using the force that F equals to ma, the normal force, and of course when F when we have to use the total force equivalent to a total of force in x-axis and the total force in the y-axis. So like this topic, okay, it's very good examples of the equilibrium, right? So what is equilibrium? Equilibrium means, okay, object either at rest or moving with a constant velocity. Okay, with the constant velocity. So in this case, the net force is acting to the object is zero. So we can look at the problems like for examples, the equilibrium. When the object is in equilibrium like this, you're hanging things, okay, like the hanging traffic light. This traffic light doesn't move either in x or y axis at all. Okay, so of course, okay, it needs we can say that the traffic light is in equilibrium. Okay, in equilibrium, meaning that we should consider every forces fx of fy must be equivalent to zero. Okay, must be equivalent to. That's why stated here that summation of fx will be zero and also summation of fy equals to zero. Okay, before this we already did the part where the Newton's law about the static frictions, whatever you call it, right? And how to use the mu k and mu s, okay? And of course, this F will equivalent to ma because we should state the Newton's second law, F equals to, meaning that total F equals to ma. But on the next part, this is the topic where about the equilibrium. Equilibrium means object doesn't move. Okay, so fx equals to 0, then fy equals to 0. Okay, so like the traffic hanging light, obviously we must we should write or we should sketch the free body diagram. Okay, you must be able to draw a free body diagram, and for this example, make sure that the free body diagram always, okay, let's say, okay, is always pointing. So this is the point where this is the center of mass, center of the traffic light. Okay, so the T1 should be going this way, T2 and T3. Okay, every arrow, okay, must be pointing outwards, mesti point dia keluar daripada sistem itu. So let's say system inilah sistem traffic light, so it must be pointing outwards. So that's how it means by a free body diagram. Okay, so remember, okay. All right. So again, you must consider the component. Okay, you must be able to write down a component like this. Okay, or how can be negative or positive shouldn't be a problem anymore, because you should know that if everything is going to the left, it should be considered to the left, or to the bottom part should be equivalent to negative. Okay, negative. So that's why when you are looking at the negative, so you are looking actually at the components that are going to the left and also to the bottom part. Okay, so this is how you solve the problem. Let's say the summation of fx. Okay, the summation of fx. This one, fx equivalent to 0. So fx is what? Fx is this. This is all fx, meaning that you should add everything in x-axis. And for y-axis, we consider everything in y. So don't try to complicate between fx and fy, because y is only on y-axis. And of course, look at the normal force. Okay, when you have an incline, okay, incline is very good examples on how you can practice your vector components. Okay, because in incline is always stating like this. Okay, what you can do always must be able to draw a free body diagram. Look at the free body diagram here. Remember about the normal force. Normal force is always perpendicular to the surface. And mg, look at the mg here. Okay, mg is going straight to the center of the earth, and normal force is 90 degrees to the surface. In this case, the surface is 30 degrees inclined. Okay, right? So look at the angles. Okay, when you have a 30 degrees, so how can we get this angle over here? Okay, and remember that this mg, when you have an angle, must have its own components. So this is mg what? Okay, this is mg cos theta. Okay, don't bother about the negative or positive. Just write down the mg sine or mg cos. How can we know that one is mg cos or mg sine? That depends on the theta over here. If the theta is in between the vector and also the mg, the vector and paksi y, so maksud dia yang paksi y lah akan pakai cos. So macam mana pula dengan angle yang tak ada dekat sini? So dia akan terus dapat sin theta. Kenapa dia buat negatif dekat sini? Okay, because of dia ada satu, nampak ni ada tali. So tali ini yang mengikat pada pokok ini ada tension. So that's why bila kita draw a free body diagram, okay, remember one thing. Okay, this is mg, contoh dia mg sin theta. So ke arah sana, the direction dia ke bawah, t ke arah atas. So nanti bila kita write down the equations, it should be tolak lah. Okay, so maksud dia kalau tengok how they can write their answer. Okay, look at. Okay, so in fx apa ada? T plus 0. T means kat sini lah. T plus 0. Plus 0 means here, but don't bother about the n, because n in y-axis. So this kosong ni sebenarnya ialah pada untuk normal force. And minus mg sin theta equivalent to 38.6.5 Newton. That depends on what we want to calculate. Okay, so in y we have n and we have mg cos theta, and we doesn't have any more things. That's why n minus mg cos theta equivalent to 66.7. Okay, always look at the examples. Okay, when you look at the examples, try to do it on your own. Okay, meaning that you have your own video. Bila sambil-sambil tengok video tu, pause, lepas tu try apa masuk dia. Okay, this example contained in your textbook. Okay, so always when you have examples, try to replicate how they can answer the problem, right? So that's how you learn some things. Okay, do the examples again until you understand. Okay, don't memorize the step, but you need to memorize you should know how to make sure that you understand the concepts first. after concepts, then equations. Okay, then you know how to substitute the information or the value given. Okay, so this is the examples of by using the same equations. Okay, we can actually get the acceleration and maybe other things that involve the motions. Okay, so like this one also. Okay, we can find the acceleration. Okay, so this one is something related to tension, like uh, I already explained to you. Okay, about this one also the apparent weight. Okay, so let's look at
Example of this. Okay, this example, weighing a fish in the elevator. Alright, this woman weighs a fish with a spring scale attached to the ceiling of an elevator. While the elevator is at rest, she measures a weight of 40 newtons. So when it's at rest, not moving up and or down, the weight of the fish is 40 newton. What weight does the scale read if the elevator accelerates upward at 2 meters per second? So first upward, the elevator moving with 2 meters per second. And B, what does the scale read if the elevator moving downwards at 2 meters per second also? And C, if the elevator cable breaks, what happened? What does the scale read? Let's go up. Okay, let's take a ride on an elevator going up with 2 meters per second. So what you have to do, you draw the free body diagram over here on the fish there. Okay, so you get the tension of the cable is upward, okay, over here, and the weight of the fish. So you apply your Newton's second law. Okay, so T minus mg equals to ma. Okay, and you substitute all the values that given to you, the weight and the g, and you get the mass here is 4.08 kilogram. Then you substitute that value into this equation, thus you're gonna get your apparent weight of the fish or the tension is 48.1 Newton, which is more than 40 Newton. Okay, so the fish is heavier when it's riding upwards. Okay, that's what apparent weight meant about. Okay, let's take a ride downstairs. Okay, so when we go down, what is the weight of the fish? So T, okay, it goes down. Alright, T minus mg, okay, T minus mg is with T minus mg equals to negative ma, because the acceleration is downward. I always like to do like this, T minus mg equals to negative ma, and then you can rearrange this equation and you will get this one. Okay, and this value is obviously lesser than 40 Newton. That is the apparent weight when you go down. Okay, and the question C asking what is the weight when the cable breaks. When the cable breaks, there is no tension, then there is nothing. The cable breaks. Okay, alright. Okay, next is block on a ramp. It's something like inclined plane, but this one you need to associate with this one, the friction. Okay, it could be kinetic friction and it could be static friction depending on the situation on the object. Okay, axes are rotated as usual on incline. The directions of impending motion will be down the plane. Friction acts up the plane, opposes the motion depending on the direction of the motion. Apply Newton's law and solve the equation. Okay, let's look at this example. You have a block with mass 2.5 kilogram resting on a ramp. Resting, okay, it's not moving. If the coefficient of static friction between the block and the ramp is 0.35, what maximum angle can the ramp make with the horizontal before the block starts to slip down? Okay, so please extract all the information given here. The mass is 2.5, the mu s is 0.35. They ask for theta. We need to find the theta before start to slip down. okay, before it starts to move. So that is you need to find the maximum angle. Okay. First thing first, as usual, always draw the free body diagram. So free body diagram here, you resolve all the components. So you have normal is always perpendicular to the object. Okay, this is the weight directly downward. And this is the weight component mg sin theta. This is another component in y direction mg cos theta. So it starts to slip down here, right? But it won't slip down yet. So the static friction must always oppose the motion. So this is the static friction force. So apply the Newton's second law in x and y directions. For x direction, you see mg sin theta. Mg sin theta over here, you have to minus whatever over here, minus this one. Mg sin theta minus mu s, and because Fs equals to mu s, and for n capital letter or small letter doesn't matter, just the same. Okay, and then equals to 0 because it's equilibrium, right, at rest. Okay, the second one in y direction, meaning whatever you got over in y direction, it's just n minus mg cos theta equals to 0. Thus you will get n equals to mg cos theta. Okay, after you applied this one, you can substitute inside here because you need this n equals to mg cos theta to be substitute over here, meaning over here, the mu s end. So once you get everything, you substitute inside the equation, then you should be able to find the theta. Okay, alright. Okay, I have another example, object on inclined plane, but this one, the object with acceleration. Okay, it's given here, an object of 2 kg pulled up this way by a force of 50 Newton, and the surface has coefficient of friction of 0.2. Find the acceleration of the object. So you need to find the A. Okay. First thing first, always draw the free body diagram because this is direction and this is direction of x and y. It's x and y. So this is the applied force. This is the friction force. This is the normal force. And be sure that this weight has its component. The component of this weight is here is W cos theta. I'm sorry because of my writing is terrible. And over here, right over here is mg or W sin theta negative. Okay, so in x direction you have 50 Newton, the applied force, the frictional force, okay, and also W sin theta. So be sure when you write, you substitute into the Newton's second law, you have these three forces. Okay, so object is moving along the incline, so that means acceleration in x direction, there is no acceleration in y direction. So you substitute into the Newton's second law, F(x) equals to mx. So you have 50 minus W sin theta minus the frictional force. Then you're going to end up with equation 1. Okay. Go to the y direction, you need to same thing, you need to apply into Newton's second law. F equals to NAY, 0 equals to 0. So you have normal that is pointing upward, you need to minus with the another component of weight W cos theta. So you're going to get this one, right? Automatically you're going to get this one, Fn or the normal equals to 17.76 Newton. Okay, you substitute this value into the first equation, you're going to get the acceleration. Okay, so how to get the frictional force? By using the equation, by using this equation just now that I taught you, F equals to mu n. Okay, it doesn't state here it's mu k or mu s, you just follow whatever is given here because the coefficient here is just 0.2. Okay, let's move on to the next one. I think it's the last one. Connected objects. Okay, the object is being connected with like this one. Okay, you need to apply Newton's law separately to each object. So meaning, first you apply to M1 first. Okay, look at all the direction, the X and Y direction, X and Y axis. Then you look at the M2, also apply the X and Y direction. So there is no X direction for M2, only Y. Okay. Magnitude of acceleration of both objects will be the same. So meaning acceleration here and here is the same. And tension also the same in each diagram. Meaning over here and over here, the tension is the same. And you can solve the simultaneous equation. Treating the system as one object allows an alternative method or a check. Use only external forces, and the mass is actually mass of the system. Mass of the system means mass of M1 and also M2. Okay, let's just go straight to the example. Look at this example. You have block M1 with 4 kilo and ball the M2 with 7 kilo are connected by a light string that passes over a frictionless pulley, just like in the diagram. Coefficients of kinetic friction between the block and the surface 0.3. So over here, it has the mu k, okay? It's 0.3, and the question asking for acceleration for two objects. Be mind that in connected objects, acceleration is the same. Okay, over here it has acceleration, down here it has an acceleration. Okay, and B, they ask you to check the answer for the acceleration by using the system approach. Okay, let's do A first. Okay, first thing first, always draw the free body diagram. So this is the free body diagram of the M1, the block. Okay, you know the Y and X, we apply to here. So Fx T minus Fk equals to M1 A1, and obviously you know N equals to M1 G. Then you get the first equation, T minus mu k M1G equals to M1 A1. Okay, how did I get this one? You just expand this one. Expand the mu k. You know that, sorry, expand the Fk. You know that Fk equals to k N. Okay, when you expand this one, that's why you will get this one. Okay, this is the first equation. The second equation is coming from the ball, the M2. So you can see this is just like the output machine. So T minus M2G equals to negative MA. Why is it negative MA? Because acceleration is downward. So that's why you put negative here. Okay, so you get T minus M2G equals to negative M2A. And once you get 1 and 2, please just, since they say that tension is the same for this system, you just make it the same, equals this equation 1 with the equation 2 like this, then you should be able to get the acceleration. Okay, and just substitute all the value, then you get the answers. This one for acceleration and the tension. For part C, they ask you to find the acceleration using the system approach. System means they taking into account the total mass of it. So the total mass of it is just M1 plus M2. So that's why they just add up the M1 plus M2. Okay, but it's actually the same. When you look at this one, it's actually the same as this one. But I suggest you, okay, in my opinion, I suggest you to do it one by one. Meaning focus on object 1, then focus on object 2. Just find the equation and and solve this simultaneous equation. Okay. Okay, last example for
Okay, so I think that should be enough for the examples, and that should be the end of the chapters for chapter 4. And of course, afterwards you will learn in chapter 5 and chapter 6. Okay, the chapter 5 will be work, energy, and power. So you can right now you can always do the tutorial 3. You are allowed to do the tutorial 3. You are welcome to do the tutorial 3. So we will continue tutorial. We will discuss the tutorial 3 next week. Okay, and please do some revisions. Okay, towards the chapters and look at the videos. The videos I've already completed with the explanations about the topics, and it should be enough for you to understand the concepts. There are a lot of concepts in these videos. Videos, of course, try to manage to answer or try to look at the videos one by one. Maybe you can try the examples. You can always calculate back all the examples given in order for you to do to understand the physics concepts inside every videos. Okay, so I think that's all for today. Thank you very much, everyone. So that should be the end of the class. Thank you. So assalamualaikum warahmatullahi wabarakatuh.